Hello and welcome. So we're using the following matrices to answer each question below. Now, as you start all of the stuff, the biggest thing that you want to start out with is it possible? Okay, and we'll run through that as we go through each example, so let's just dive in. First thing we have is 2 times z. This is a scalar to a matrix. That means that you have a 2 out front, and then your matrix z, so 0, -5, 4, -6, -7, 9. Okay, so we just grabbed the z matrix, brought it down. Okay, now what the scalar 2 in front of it is, that just essentially distributes to every one of these terms. So that's 0 times 2, 0, right? 0 times -5, -10, 8, -12, -14, 18. All right, that's all scalars out front do, is they just distribute to every entry within the matrix. So then our answer for 2z is essentially that matrix right there. So all you'd have to do would be put this into your box, and you would do that by following this purple directions right there. Just click on the matrix tab, enter in the dimensions, put in your matrix. Okay, and that would be that answer. Now next is when we have to start checking to see if the matrix exists. So we have 2g, -2g plus 6e. Well, first off, if we're looking at this one, if we have -2 times g, which is going to be a 2 by 2 matrix, plus 6 times e, which is a 3 by 2 matrix. Now, in order to add or subtract any matrix to another, they have to be the exact same dimensions. Meaning, if you want to add a 2 by 2 matrix to something, that something has to be a 2 by 2 matrix, right? So where this is a 2 by 2 and this is a 3 by 2 matrix, those are not the same dimensions, which means that you cannot add these together. The resulting matrix that you're trying to do here, it doesn't exist, DNE. Okay, so that would be it. Bam, finished. Okay, next one, we have 3z plus 5e. So we do 3 times z, where z is a 3 by 2 matrix, plus 5e, which is also a 3 by 2 matrix, which means they're the same dimensions. We can actually do this addition. So let's go right for it. So we have 3 times z, so 0, -5, 4, -6, -7, 9, plus 5 times e, which is 2, -2, -5, 1, 3, and 3. Okay. Now, all we got to do is take care of your scalars first, the numbers out front. Want to deal with these before we do anything else. So I'd say, all right, well, let's multiply that 3 in. So our first matrix will be 0, -15, 12, -18, -21, and 27. The next matrix will be 5 times the next one, so that should be 10, -10, -25, 5, 15, and 15. Now, we have no more scalars out front. You can now add the two matrices together. And how addition works with matrices is that the corresponding entries will essentially add to each other. So 0 plus 10 is 10, right? So equals 10. Booyah! That's your first one. And then you do the same process where -15 plus -10, that's -25. Right? And then you keep going down the list, right? 12 minus 25 is -13, right? -18 plus 5, also -13, right? -21 plus 15, -6. 27 plus 15 is going to be 40, nope, not 43, that's 42, 42. All right, so whatever entry is, right, top left with top left, top right with top right, middle left with middle left, right? Always keep the entries corresponding to each other. They don't add to something else. And that will be your answer for 3z plus 5e. Okay, so you just take that matrix, again, use the matrix tab, put in the matrix dimensions, you're good to go. All right, last we have a minus 7g. So we take our a, 2 by 2, minus 7 of your g's, which is another 2 by 2 matrix. They're both the same dimensions, so we can actually do that. So it's not another DNE, an actual answer for this one. So we take our a, which is going to be 3, 2, -5, -3, minus 7 times g, which is 2, 5, -1, 0. So once we add these together, then that will be our final answer for a minus 7g. So first off, I would bring that scalar through. Now, when I have negative scalars, how I would tackle that is I would bring through the -7. I want to just bring through 7. I would bring -7 through the matrix. So that way you're not doing like extra subtraction and worrying about signs as you go through it. So the first matrix stays the same. Right, and then the second matrix I would just do plus, and then I would distribute -7 into everything. So 2 times -7, -14, right? And then just keep going through all of the entries. Because now it's just simple addition, and now you can just do entry to entry, right? Nothing crazy going on. 3 plus -14, -11, right? And then just keep going from there. And then we have 5 plus -35, -40, right? 2 plus 7 is going to be 9, -3 plus 0. Oh, wow. Still writing in highlighter. Whoops. -40, 9, and -3. Okay. And that would be it for that one. So let me... Oh! Never mind. I thought I wrote a matrix wrong, and I was like, holy smokes. So that'd be -2. Oh, I dropped a negative. There it is. I'm like, ooh, hold on a second. All right, so then that would be +14, and that would be not -1. That'd be 17. That was a close catch. There we go. And that would be your true answer for a -7g. And then same thing, open up your matrix tab, put in a 2x2 matrix, and add in your entries, and you're good to go. Okay, so not too shabby. Biggest thing to remember is when you have a scalar, make sure you bring through the negative, right? Makes your life a little bit easier, turns into addition between your matrices. If you have multiple matrices you're adding, just make sure they have the same dimensions. And those are the two biggest points for matrix operations with addition and subtraction. All right, thanks for watching.